I'm going to get started in a minute or two, but just before I get started, if anyone would like a copy of these slides, I will point out that there is a URL right here. You can use this to download the slides to all of the HAPI FHIR tutorials. That includes the beginner session that was yesterday, it includes the server session that was earlier today, and includes the slides we're about to see. So all of those slides are available, and they are Creative Commons licensed and all that goodness, good stuff too, so you're welcome to take them and teach HAPI FHIR yourself if you'd like later. Okay, so this is the HAPI FHIR for Java developers advanced tutorial. So this last session is it's a bit of a hodgepodge. So it's just a bunch of assorted topics to do with HAPI FHIR. Naturally, over the course of the 3 tutorials we have on HAPI FHIR, we have definitely not covered all of the functionality. I think it would take many more sessions to get through every last thing that's in HAPI FHIR. We haven't touched on, for instance, the Android library. We haven't touched on, what else? There's a bunch of things we haven't touched on anyway. I will mention if there is anything that we have not covered that is a part of the library, or you're wondering how something is done or anything like that. This presentation is a little bit shorter. We've got time at the end to talk about any topics that you guys want to cover. I will also, of course, be around for the rest of the event. So certainly, by all means, in the hackathon area, if there's something you want to know how it works, feel free to grab me and we can talk about that. But we'll cover a couple of interesting things here and see how long that takes. So I'm going to cover during this presentation the web test page overlay as well as validation topics. Those are the 2 main topics for this session. Validation we're going to cover here, and there's actually also a validation session tomorrow. So there'll be some repeat in the validation session tomorrow if you want to learn even more about how validation works in HAPI. So let's start with the web test page overlay. So if any of you guys have ever used our public test server, that's firetest.uhn.ca, you've probably become familiar with this UI. The UI that we have, this UI, let me actually go in there and give you a little sample of how that thing works. So this is the UI I'm talking about. Of course, this thing, it's kind of nice for playing with, the API. I can go into specific resources. It lets me build up searches. It's got a nice way of sort of building up queries. So if I want to go into the patient resource, I can see what search parameters are in there. Let me actually build one just to show you. So I will go in, I'm going to look for patients whose name matches James, and I will click search. And of course it will go through, it will search for anyone named James, and naturally the network in here is a little slow, but there you go. So it's done a search for patients, it shows you what URL it generated, and then it shows you all of the results that came back. And of course these are all a bunch of people whose name is James. So a nice little UI that lets you lets you play with the API. The really nice thing about the test page overlay is it is not sort of using any internal hooks that sort of are built into HAPI. It's actually just plain acting as a normal FHIR client. Going through the front door, it asks for the server's capability statement, it builds up this API based on whatever resources the server declares that it conforms to. It asks the server what search parameters do you support, and it puts those into its UI and all of that stuff. So essentially, if you've got a FHIR server, whether it's a HAPI FHIR server, this could be an implementation of Furore's Vonk server, this could be an implementation of any other server, you can talk to whatever FHIR conformance server you've got using the Testpage Overlay, and it's sort of a nice tool that layers on top and lets people play with it. So the way you use this thing, let's go back into the browser. What is going on? So, yeah, as I was saying, the way this thing works is it loads up the FHIR capability statement from the server in the background, and then it invokes operations. So if you are trying to, if you ask the Testpage Overlay to do a read, it's just doing a normal HTTP GET over the, just like any other client, and it's displaying the results just like any other HTTP client would be doing that. So the Testpage Overlay works as a Maven overlay, a web overlay, which is kind of a funny concept. If you've never worked with a web overlay before, they're neat little, they're neat projects. The way they work, if you've ever built a web project in Java, you typically build these WAR files, a web archive file. And your web archive file is a collection of your static resources, your HTML blocks, some Java classes, things like that. Maven web overlays are kind of neat things in that you stick a Maven overlay into your Maven POM file, and what it allows you to do is to override any of the files that are sitting inside the packaged WAR file with your own definition files, which is really, it's a weird thing to explain, but ultimately what you can do is on the UI, basically when you look at the UI, you'll see a whole bunch of things which are all sort of defined as web resources. We've got HAPI FHIR's branding and HAPI FHIR's colors and all of that stuff, a bunch of CSS files. Any of those individual resources you can override with your own definitions. So if you wanted to create a version of the HAPI FHIR, the test overlay that has your company's logo on it and maybe your company's colors or something like that, you could override any of those bits with your things and make it look the way you want it to look. It's the hardest thing to explain in the context of one of these things. So the easiest way to sort of show you how that works is to actually kind of go and show you the examples, which is what I'm going to do. So what I'll do first off, so from this slide, and again, I mean, you'll have access to all of these if you go and get the slides, and I'll put the URL up again at the end. If you go and look at the source for the HAPI FHIR Testpage Overlay, and I'm going to go there right now. So if I go into the source, you'll see that I've got a whole bunch of these HTML files, and every one of these corresponds to one of the pages you saw in the Testpage Overlay. I'm going to go to the home.html, because that's the plain home page. And I will go down, find some of my content. So here's content for post a bundle. There's a bunch of instructions. You'll see up at the top there's CSS files and all of that stuff. Basically what I do is in the FHIR Starters page, you will see there's this project called HAPI FHIR Starters Testpage Overlay, which is basically an example project using the overlay. And what I do is I can basically replace any of those files with my own copies I want. So what I've done is this template banner file is the file that contains sort of the message at the top. And what I've done is I've replaced the overlay, I've replaced the text which goes on the homepage with my own text of this is the HAPI FHIR Starters tutorial server. Which is probably still not an entirely satisfactory explanation. This is the kind of thing you kind of have to play with to sort of really get a feel for how it works. But of course, up on the FHIR Starters webpage, this project, HAPI FHIR Starters Testpage Overlay, is where you can go and sort of check the project out. And once you go in, you can start sort of make changes to the code, deploy it, try it out, and you'll start to sort of get an appreciation for what changes when you make changes. And from there, you can sort of figure out how you add your own company images and change style sheets and stuff like that. So, I mean, the whole concept here, this is not a great explanation of how you do this, because it's really something you have to do hands-on to totally get a great appreciation for. But hopefully you've got a sort of a general sense, and I will be available the rest of the time to sort of, walk you through how all of that works, if any of that is a little bit confusing, which I think it probably is. Cool. So that is all I'm going to say about the test page overlay. Now I'm going to talk about extensions for a little bit. So naturally in FHIR, everything we've talked about to date, we're talking about basically using the resources as they are. And I mean, of course, your patient definition has a whole bunch of fields which are all sort of built into the patient resource. But if you're really trying to solve any real world problem, chances are you've got some piece of data which doesn't fit into the model. I mean, the example I use, I mean, if let's say I'm building an ophthalmology system, I probably care about the patient's eye color. And of course, the 80-20 rule that we use in FHIR says that 80% of systems out there do not care about patient's eye color. That's really not something most EHRs track. But if my thing is I'm building an ophthalmology system, of course, it's super important to me to have an eye color sitting in there. So what I'm going to do, of course, is I am going to define an extension for my system for tracking patient's eye color. That all makes sense, but naturally I want to add that into my model. So there's two ways I can do that. Basically, there's two ways I can sort of interact with these extensions and add them into my model. First, I'll show you the easy way. And the easy way is that basically anything in the model has these methods that allow you to add extensions directly on them. So I've got one example here. So I'm creating a patient, and I create a new instance of a patient, just like I always would. I'll give them a name, and then I'm going to set this sort of patient importance flag. So what I'll do is all I say here, PAT, that's my patient variable, I call add extension, and add extension really takes two properties. First I say set URL on that, and I give it the URL for an extension definition, and then I set a value. So in this case, I've got a codable concept, and probably in a real world scenario, I would give it an actual code and a system. For the purposes of demonstration, I'm just going to set a text on there, so I'm saying this patient is a VIP. So this sort of simple example shows us doing that. And one more, so birth time and birth date, that's another common thing we want to do. So I set the birth date example, or I set a birth date, and then of course the extension in FHIR for birth time is an extension not on the resource, but on the birth date element. So what I do there is on the birth date element, I'm adding extension directly onto that data type, and once again, I will set URL, and I will give it the URL of an extension, and I will call set value, and in this time, I'm giving it a data type of time, so time type, and now I've set the birth time. So once I've got my patient resource all constructed and populated and all of that, I go through the usual thing of creating a parser, and I encode it, and what comes out? Oh, I don't even have an example of that. Thought I did. So what comes out, of course, is I will basically get a resource serialized that includes those two resources coming out. So that's the easy way of doing it. I mean, basically here I'm adding, I'm calling a couple of adders, I'm adding things in. There is a second way that you can do this in HAPI, and this is by creating custom classes. So this one's a little bit more work up front because, of course, this means that you've got to create your own custom class definitions. But it does have sort of the nice advantage that you get some static sort of compile time checking on your extensions if you do it this way. So, I mean, this strategy, I've used it a lot. And the reason I kind of like this strategy is because it allows one person to sort of write classes that have all of our extensions. And then everyone else can use it. And they basically, if they're using the extensions wrong, then their code won't compile, which is quite nice. So the way that you do this is actually by extending whatever it is you're trying to add the extension to. So in this case, I'm creating a patient class, and I've called it example 32 extended patient. The numbering is just so that you can find that class in the GitHub repo if you want to go looking for it. I've called it extension 32 extended patient, and what I do is I extend HAPI's built-in patient class. And I have to give it this special annotation of resource def, which is HAPI's annotation that says this class is a resource definition that I want you to use. And then I add a field for my extension, whatever that extension is. I give it whatever the data type is that I want the extension to have, and then I put these two basically little annotations on it. One at child just says that this is a field of some sort that I'm going to be adding to my resource. And the second one at extension tells it, is this a, what is the URL that we're using? Is it a modifier extension? And then we've got this one other property defined locally, which I'll skip that. I'll talk about that a little bit later. So bottom line, you put all of this, put these two annotations on, and once you've got all of that on, you've now got extensions that will serialize automatically, that will parse automatically, and that you can get nice sort of static compile time checking against, which is kind of cool. So that's it for validation, or sorry, that's it for extensions. Let's talk about Validator for a little bit. So validation is, it's a pretty broad topic, and this is kind of the bulk of the rest of the presentation is talking about validation, just because it's a big and very varied topic. So, I mean, before we even talk about how to do validation, there are lots of considerations for adding validation in. I mean, I've personally built lots of production systems in FHIR. I'm sure I'm sure a lot of you guys have too. And validation is the sort of age-old question, just because you can write a really strict server that validates and rejects any data that's not conformant and is really strict. And I mean, that's great because it means that you will always have conformant data sitting in your system, and people will know if they're trying to send you non-conformant data. But it does mean, of course, that your server is going to reject data if it doesn't comply, and that potentially means you're going to lose data or not be able to save it. Validation, of course, always has a cost as well. So validation, it takes time. So if you're intending to process thousands of resources a second, you definitely pay a performance penalty if you're going to run through validation for every single thing you send through. So, I mean, these are all sort of considerations that you have to sort of keep in mind as you do it. I guess the other thing is, I mean, there's a few other points. You can sort of decide, do you want to validate data as it gets saved to the server? Do you want to validate data as it's being returned from the server? Are you interested only in the structure? Sort of, do you want structural validation, or are you really interested in sort of deep inspection of the content? Do you want semantic validation as well? Meaning, things like, if this is an observation, we've decided we only want LOINC codes in our observations. So that would be an example of doing some semantic validation where we're saying, this is not valid if we're not using LOINC, as an example. So, I mean, all of these are considerations for how and when you validate, and naturally, there is no right answer to any of this stuff. This is one of these things where, I mean, we've done systems where we have to have data perfect all the time, so we validate very strictly every bit of data that goes in and every bit of data that goes out. We're willing to pay the performance penalties that come with that, and we accept that we will reject data that's not perfect. We've built systems that work that way. Much more often than not, we don't do that. Ooh, that's turning off. Much more often than not, we will go the other route, where we'll probably be pretty strict with our systems when we're developing them. So the development version of our server has every single bit of validation turned up as high as we possibly can, so that we catch errors. Oh no, stop turning off. You're ruining my demo computer. Okay. See if it will behave. There we go. So as I was saying, much more often, in development, we try and turn the knobs as high as we can so that we catch problems as we're developing our software. But when we get into production, we usually will turn those knobs down just to avoid any possibility of losing data. And I mean, that does mean that sometimes bad data gets into the system, and this is a consideration we take, of course. I mean, sometimes we have to do cleanup exercises because the system starts misbehaving. This is the real world. I mean, this is the way it is when you're building software, of course. So these are all considerations. And I mean, my point here is that I cannot tell you how to build systems. I certainly can't tell you what's right for the problems you are building, or the systems you are building. But at the minimum, I can tell you how to do validation. So that's kind of fun, at least. You can use these tools for that. So there are, within HAPI FHIR, there are sort of two layers of validation, and I'm going to describe both of these. And they both sort of serve different purposes, and they're both useful in their own ways. I've probably got them sort of left to right in the opposite order. I'll talk about them. So I'm going to start with Parser Error Handler. So the Parser Error Handler is concerned really only with structural validation. The Parser Error Handler is a module that, as we're going through and parsing resources, looks for simple structural errors. So what I mean by that is, A, is your data well-formed? B, are you conformant to sort of just the basic rules of how we encode FHIR? So for example, the Parser Error Handler would allow you to say, okay, this field, there's an element, for instance, in your JSON document that does not exist in FHIR. I mean, let's say we're parsing a patient, and we found a JSON key called foo. The parser validator can catch that and flag it or error it or whatever. And I'll show you all of that in a minute. It catches those sort of basic errors. On the other hand, the actual validator gives you semantic validations. The validator is able to detect much deeper problems. It's able to detect things like FHIR's got a rule that status in an observation is required. So it can throw out an error if we don't have a status and we've got an observation. Or we've got invariants. So things like if field 1 is populated, field 2 has to be populated. Or if field 1 is not populated, field 2 is not allowed to be populated. Those types of rules are sort of semantic rules that are baked into FHIR. They're not sort of structural stuff. Like it's not that you're not a valid JSON document, but it is that, you know, FHIR, you're not conforming to FHIR's rules, and the validator allows you to catch that stuff. So let's look at the validator first and sort of show you how that works. So HAPI's validator is built on this concept that you use the validator by plugging in any of a number of modules into it that provide different types of validation. Once you've plugged in one of these modules, these green things, which are modules you plug into the validator, you can pass in any of sort of 3 possible inputs. You can pass in parsed HAPI resource objects. So you can pass in things like your patient.java class instance, or your observation, your parsed Java observation or whatever. You can also parse in raw content. So if you've got like just a string with a raw JSON resource or a string with a raw XML resource, you can pass those into the validator as well. The validator will run through, it will run its validation, and it outputs 3 things. The first, it outputs just plain a pass-fail. And the pass-fail is just simply, do we have anything that was flagged as being an error or a fatal error? And if so, then that's a fail. Otherwise, if there were warnings only or there was nothing came out, then we've got a pass. It will also return to you a nice list of all of the issues. So do we have any info level stuff, any warning level stuff, any error level stuff? All of that comes back, and you could display that to a user or do whatever it is you wanted to do with it. And finally, the validator will give you an operation outcome resource. And this is kind of useful if you're building servers, just because a common thing you want to do in servers is run a validation and then return an operation outcome to your client. The validator will give you one such operation outcome you can use to return to your clients. So there's a couple of these validation modules. And you can kind of see them listed here. We've got a schema module, a schematron module, and then these instance validator modules as well. And I'm going to describe what each of these things do in the next couple of slides. So the schema and schematron validator modules, you typically use both of them as a pair. What they do is they use FHIR's built-in schema definitions and schematron definitions to validate a resource against those, basically against the sort of built-in definitions. So what I mean by that is when the FHIR specification itself gets built, like when we're actually building the FHIR spec, one of the outputs of that is a set of schema definitions for all of our resources and a set of schematron definitions that include all of the invariants. So between the two of them, they do things like, say, that example I gave before, an observation resource has a mandatory status, so the status has to be there. And a bunch of invariants. I'm trying to think of an example of an invariant. There are invariants like that say things like identifiers, I believe, have to have an actual identifier value in them. I think that's an invariant. Either way, there's a bunch of rules that say if field 1 is populated, then field 2 has to be populated, that type of thing. All of these are sort of codified in these schema and schematron validation, in these schema and schematron files, and all of those are sort of bundled up within HAPI. So the nice thing about running the schema and schematron validator is there's not a whole lot to it. Basically, if you add those 2 modules, the 2 will run. They're actually quite well, they perform quite well, oddly enough. So if you want sort of just some really nice, fast validation, schema and schematron are a great way to do that. If you haven't configured any modules in the validator, by default it just picks up the schema and schematron validator modules, and it will just run those. Otherwise, if you register any modules, then it will override that and not just automatically register the schema and schematron modules. In order to run this type of validation, you do need to add a couple of Java dependencies to your project. The first is this flock schematron library, which is an implementation of the schematron specification. And more importantly, you need to add the HAPI FHIR validation resources for whatever version of FHIR you're trying to support. These jars are quite big, actually, and so this is why we don't include these jars by default in the library, because they have all of the schema definitions and all of the schematron definitions, as well as all of the structure definitions, a whole bunch of stuff that's needed for validation. Each one of them is about 10 megabytes, so we don't include them by default. You have to manually go in and add them, but if you're writing a server project, probably 10 megabytes isn't a huge deal to you. On the other hand, if you're writing an Android project, it probably is, so that's the deal with that. And you pass your inputs in, and out comes something. So let's look at some code that shows you how that works. So in our example, we create an encounter resource. An encounter is one of those resources I was mentioning where the status is required. So an encounter resource is not valid if it doesn't have a status. And this is FHIR's rule. FHIR says that encounter.status is 1-to-1. So we create an encounter resource. We're going to give it an identifier, but you'll notice we do not set a status on it. So we have just created an invalid encounter in these first 2 lines of code up here. What we do to validate is, like I was saying in the server and in the client tutorials, the first thing you always do when you're dealing with HAPI FHIR is you create an instance of your context. So we say FHIR context.4dstu3 because we want an R3 context. And just like the client, so with clients you say, context.newClient. For validator, you say context.newValidator. So we ask the client, or we ask the context for a validator basically, and that gives us back this nice thing of type FHIR Validator. And on the validator, you'll notice we don't even register any modules to it. I was saying that by default we're going to get schema and schematron, so I don't do anything to this validator. I just right away call validator.validate with result, and I pass in my encounter, and I'm going to print out was it successful, and I'm going to print out the operation outcome that the thing gave back to me. And I really hope my next slide, yep. So my next slide is that, and if I pass this through, of course, success is false because that was not a valid operation outcome, or that was not a valid encounter. And what I've got back is an operation outcome that describes the error. Now, I use this as kind of a simple example. Schema is great because it performs quite well. Schema and schematron are nice performant things. The one real big downside to doing schema and schematron validation is that your error messages tend to be really difficult to decipher. So remember that I said the problem with this encounter is that status isn't there. Status is mandatory. And of course, looking at this error, you can kind of get at what it's saying, but it's really not that clear. It's saying the content of element encounter is not complete. One of identifier, comma, status is expected. So in this case, it sort of gives you a hint. I mean, you can look at that and figure out, okay, status is the thing we want. But it's a little bit weird because the identifier is not required. This is just, what it's saying is that either the first element should be identifier or status. Sometimes the errors that come out of schema validation don't even mention the actual thing that's missing. It's just the nature of schema validation. I see a few smiles. You guys have probably lived through the horrors of schema validation. It is what it is. On the other hand, it does tell you if something is wrong, and there are better ways of doing it. So we started with the hard way. That's it. If you want to validate plain strings, so here's another example. I have created an encounter resource. This is, let's say I parsed it or I got it from somewhere outside. I've created a completely empty encounter. I can pass that in just as though it was a parsed Java object, and I'm going to get the exact same type of response back. So that is the first way we can do validation. I use it occasionally, but these days I'm much more likely to use profile validation, which is actually a much more sort of interesting way of doing validation. So profiling in FHIR is it's a complicated topic. I will certainly say that. I'm not going to get into spending much time talking about how you build the profiling resources because there are other tutorials at DevDays for that. But I'll sort of describe the basic concept to you at least. So in FHIR, we have a couple of special resources that are used as what we call the conformance resources. The first one we've got is this resource called structure definition. And structure definition is a special resource that is, as its name kind of implies, it's a definition for a structure. What do we mean by that? It's basically a resource definition. So let's say we're talking about patient. And let's say in our server, we either want to be conformant to just plain how do patients look in FHIR, or even better, we might want to constrain patient for the uses in our system. So let's say we're building a system and we want to say that name is always required for our system. So, name is not a required attribute of patient in general, but for our system, we're going to make patient required. The way we do that is we create a structure definition that declares that for our system, patient is a required attribute. The easiest way to create one of these structure definitions is with the Forge tool, and Forge, of course, is a tool produced by FHIR. It is available, you can use it for free. I'm not going to get into how you use it in this because it's a fairly complicated subject, but there are tutorials here where you can learn to do that. The point for now is that the output of what you're doing is one of these structure definition resources. There's a couple of other resources that are used as well. Value set and code system are the main other ones, and they are, of course, used for code bindings. So another thing we might do is try and create sort of rules that say we're only going to allow certain codes in certain fields in our resources. The best example of that might be, let's say we're building a lab system. We might decide that all of our observations need to have LOINC codes, and it might even need to have a LOINC codes from a specific value set. So a subset of LOINC is what we're allowing. The way we do that is by defining value sets and defining code systems. And all of those are sort of inputs that we use into the validator to sort of do validation. So essentially, the profile validator defines this special instance, this special class called iValidation support. And iValidation support is an interface, a Java interface, that's used by the validator to fetch structure definitions, to fetch value sets, to fetch code systems, and it uses all of that for validation. We supply a couple of implementations within the HAPI library of this iValidation support. There's one that will just bring all of the default FHIR definitions, so it will just fetch all of the structure definitions and value sets and code systems which are bundled within FHIR itself. But you could also roll your own. So if you've got your own structure definitions and you've got them, in a text file or somewhere on your class path or sitting in your database or something like that, you can create your own implementations of iValidation support, and you can pull those yourself. We've got a couple here that are sort of listed out as our implementations of validator support. Default profile is that first one I was talking about, which will just use the default stuff that's built into FHIR itself. There's pre-populated, which is basically you supply a few and you store them in a hash map in pre-populated. There's this chain, which allows you to sort of string a couple of these things together. So you could basically say, first look in the database, then use the default definitions if there's nothing in the database. And then if you're using HAPI's JPA server, we've got a special one which looks in the JPA server's database for all of that as well. Using these things is fairly simple. Actually, I'm going to skip that. Using these things is fairly simple. Basically, here's one example. So again, I am going to create an encounter. Again, I'm not giving it a status because I want this to be invalid. I am going to create a new validator. But this time what I'm going to do is I'm going to create one of these support modules for the instance validator. So I create default profile validation support. I register that inside an instance validator. I register the validator module with the validator, which is a bit of wordy, but there we go. And then I output the results. And the really nice thing about running this validation is I get actually much nicer error messages. So this time, instead of that cryptic schema message, what I get back is element encounter.status, minimum required 1, but only found 0. So from that error, it's much more obvious what's gone wrong with our encounter. We've got exactly what was wrong with it. This code here, I mean, I realize this is another one of those things where, it doesn't make total intuitive sense explaining it as code, but fortunately up on the GitHub repo, I've numbered all of them. So this is example 22 validate resource instance validator. You will find this on the Firestarters repo, and you can take this, play with it, try adding your own support modules, try changing things. And hopefully, as you sort of play with it, it will start to make a little bit more sense how the validator modules all fit together. So that is actually all of the advanced topics, and everything that I've got actually sort of canned to talk about. I will mention I'm going to get a little bit still more in detail about how we do validation in the validation session tomorrow. So if you want to learn even more about validation, we'll talk about that some more tomorrow in those sessions. I will mention quickly that there are a few places that are great for sort of getting help on how to use HAPI. The first, of course, is our website, hapifhir.io. There's lots and lots of documentation in there. Lots of good stuff there. We've also got a Google group that is really the best place to look. So if you have not seen the Google group before, this is the URL. You can also just type into Google, into the search engine of Google. You can type in Google group HAPI FHIR, and the very first hit there is always the HAPI FHIR mailing list. There is, of course, the Zulip chat as well. Zulip is awesome for questions about FHIR, awesome for questions about everything. I always try and give this disclaimer that I try and keep up with every single social media channel that is going. But my time, there are never enough hours in the day, so I have to be honest to everyone that I'm less likely to see your question on Zulip than I am on the Google group. So if you really want me to see it, the Google group is probably a better spot to start. But Zulip is a great spot. I mean, naturally, if your question is more about how do I do something in FHIR, always, Zulip there's vastly more people on there, so you're more likely to get an answer to that type of question on Zulip for sure than you are on the Google group, which is limited to HAPI itself. The other thing I will say is that, and I always like to end on this note, HAPI, of course, is an open source project, and we are very true to the ethos of open source. We are, of course, Apache licensed. We welcome people building this into commercial products. We welcome people doing whatever they want with the library. We also welcome the other direction. We really want outside contributors, and we do our best to sort of welcome outside contributors into the mix. So I will say, if any of you guys are interested in open source, I mean, if nothing else, go check out the source. I think it's fairly easy to read, although who knows. If you're interested in getting involved in an open source project and don't know where to start, we really welcome outside contributors. I am more than happy to spend time with anyone here who wants like a walkthrough of how the code base works, or if you'd like an issue that I think would be an easy one to get started on, I'm happy to point you to that. We welcome pull requests, we welcome issue requests, all of that, and we do our best to stay on top of that. So by all means, feel free to try and get involved with the project. At this point, this slide is actually a little bit out of date, but this is taken a screenshot from our GitHub page. There have been 54 people who have contributed code to GitHub, and I bet you if I go to that now, I think the number is actually up to 60 or something. So quite a few people have contributed code to HAPI at this point. I mean, it continues to amaze me. We get pull requests every week, and almost all of them. I mean, it's very rare that we don't accept a pull request. Sometimes they need modifications, but we're very, very welcoming of that type of thing. So lots of people have contributed to the project, and hopefully lots more will. So hopefully somebody in this room I've convinced to join the project as well. That's it. Here's where you will find me, but that's all. Thank you, guys. I think we have a minute or two for questions if anyone's got any. Yes?
Yeah, you talked about using custom classes for extensions. Is there any, or do you think there could be any way of generating those, or using code generation from the structure definition rather than having to hand code them all?
Yeah, so this is an awesome question. I will say, literally over the course of DevDays, you're about the 5th person to ask me that question, which makes perfect sense. Cool, I've got 1 minute, so I'm going to answer that question, and then anybody else I'll run in the hall. So the answer to that is way back in the DSQ1 days, we actually had exactly what you're describing. We had the ability to generate code based on what was called profiles back then. The problem was they turned into structure definitions, and structure definitions kept changing and breaking our code. So we decided to stop maintaining it, and sort of once things stabilized, we'd get back to maintaining that code. We're at that point now where it probably makes sense to get it back and working, but we haven't done that yet. So it's one of these things where I really, really want to get automated code generation working again, where we can take a structure definition and generate a class. But I haven't done it yet. A few times other people have come to us and said, I'm going to try and take a crack at it, and nobody has succeeded to the point where they told me about it. If anyone wants to take a crack at that, I'll be super excited. One way or the other, we're going to get that support, but I can't give you a timeline yet, unfortunately. So that's it. Thank you, everybody. I will be around, so if anyone has more stuff they want to talk about, happy to chat.